Good evening.
This call is now being recorded.
సుధాకర్ సార్ అన్మ్యూట్ చేసుకోండి. సుధాకర్ సార్ అన్మ్యూట్ చేసుకోండి. హలో.
Are you able to hear me?
Good evening, Sudhakar sir.
Good evening, Andy. Are you able to hear me?
Yeah, now it's okay, sir. How are you, sir?
Fine, thank you.
Chandar? Hello?
Yes, sir.
The voice is clear?
Yes, sir.
Hello, sir. Can you
Chandar,
hear
are
me?
you ready?
You can go.
Chandar?
Yes, sir. Can you hear me, sir?
Yeah. Please coordinate with sir. And
Okay, sir.
Hmm.
So,
Thank you.
sir.
Yeah.
Chandar, start please.
Okay, sir. Sir, good evening, sir. Sudhakar, sir. Good evening, sir.
Good evening.
So, dear all participants, please convey your friends to join immediately because session will start within 1 minute. So, right. Good evening, all. We are honored to welcome Dr. Sudhakar, sir, as a distinguished speaker for our faculty development program. He holds master degree and PhD from JNTU Hyderabad. With over 23 years of experience in software development and academia, SAR has made significant contributions to client-server applications and object-oriented analysis and UML methodologies. He is proficient in multiple technologies, including WPF with the MVVM, C# and ASP.NET and Java, along with expertise in SQL Server database design and Windows application developments. SAR currently serves as a senior staff software engineer at Genzion Technology Solution Private Limited and has been actively involved in mentoring students. He published several research papers in software engineering and data mining. Beyond his technical expertise, SAR has attended training programs on various applications and testing tools and cloud computing. He decided to research, innovation, and mentoring makes him a valuable contributor to this FTP. Okay, sir. Thank you, sir. Thank you. Please start your session, sir. Thank you, sir.
Yeah, this is a nice introduction, Chandar garu. Thanks for introducing me.
Yes.
Pardon me. So I've not done my PhD. I've not completed. Okay, that is one correction.
Sorry. Okay. Thank you.
No
Sorry.
problem.
Yes.
Yeah, thanks. Yeah, to start with, okay, let me know. Suppose if I'm not able to hear my voice, you can stop at any time. Okay, so I'm going to present my screen. Hope you are able to see my screen.
Yes, sir.
Okay. I hope you are able to see my screen now. I'm now presenting.
Yes, sir.
Yes, sir.
Okay. So, as the introduction and the topic for the day is data pre-processing and feature engineering. So we'll start with this. So initially we'll go with what is machine learning, and then what is this, what are the agenda. Okay, if you look at the agenda, so we'll go with what are the steps involved in data cleaning, and okay, what is data sampling, data transformation, okay, encoding, feature creations, and feature transformations. What is machine learning? Okay, so machine learning, what it uses, okay, what is the advantage of machine learning, so what is the input for machine learning, okay, what are the technique it uses and what it is going to produce for us, okay. So if you look at the machine learning, as a machine learning, it is a branch of artificial intelligence. So it uses some algorithms, okay, to take the data and to predict, okay, the future results, okay, prediction, and we use it for prediction or some type of detections. And okay, if you look at the input for the machine learning can be stock data and the customer transaction data, okay, some streaming data, some email text. So as a part of machine learning, we use the lot of sorry. So as a part of machine learning, we use what different techniques, okay, machine learning techniques, and we apply our on the input data. So then we'll okay, get some outputs like okay, suppose if you take on the stock data, we can predict stock price predictions. We can do on the customer data, we can predict the market segmentations, and we can recommend something. Okay, then we can also find the spam detections earlier before they happen. Okay, so then if you use okay, the uses of machine learning, the uses of machine learning, it basically we can use what we can apply the insurance claim detections. So for example, when you are submitting claims on the insurance hospital claims, okay, we can predict what are the denial percentage, okay. So before presenting the claims to the insurance carriers, okay, we can identify, okay, what are the risks in the claims, and we can clear and we can fix those claims before submitting, okay, if you apply the machine learning techniques. And fraud detections, okay, the market analysis and the energy demands, and what are the customers, okay, the likelihood of the customers, all these things we can predict. These are all uses, I think all of you have studied okay, the uses of the machine learning. So the machine learning, the input actually comes from different sources. The input can be from cloud, okay, it can be from the databases, different databases, and we can also use we can also get the data from many APIs, third-party APIs, or we can read the data from the webhooks. Okay, so all these types of data is our input, and we use the algorithms, machine learning algorithms, and then we are going to predict the predictions. Okay, so majority of this process, if you look at any machine learning. So basically, the fundamental requirement for the machine learning or the concept is you need to identify what is the problem which you want to solve. Okay, what is the basic problem which is you want to solve? Then what is your data? Then you need to clean the data. Then you need to okay do some type of transitions and transforms the data, and then you need to extract the features from the data. Okay, so those features we can give it to the machine learning, and we can get the results. Okay, so first of all, you need to understand what is the problem you want to solve. Okay, then what is the source of the data? then you can build your algorithms. Okay, you cannot give the raw data to the okay, the models. So the raw data cannot fit into the models. So you need to do some type of processing. So let me know. Okay, let me tell you what is raw data and what are the different ways the data can be. Okay, so that's why we need to perform the pre-processing on the data. So majority of projects, say for example, if the tenure of the project, okay, say for example 1 year or 6 months, some percent, okay, some 100%, 60% of the project time we spend basically on the pre-processing. So unless if you have a quality data, okay, clean data, so then only we can get the correct results. So majority of the projects in machine learning, we are going to spend on the cleaning and pre-processing techniques. So to show that, let me share you, okay, some statistics. Okay, the data scientist spends most of the time doing what? Building training sets is just only 3%. Cleaning and organizing your data. So cleaning and organizing of your data is requires 60% of the project time. Okay, so the remaining data is basically, okay, collecting data sets, then mining the patterns, okay, then refining algorithms, okay, then so the algorithms always learn from the data and going to predict the patterns. Okay, so in this process, the majority of the time, the project time, if you take any project, first you need to identify, as I told you, first you need to identify what is the problem which you are going to solve. Then what is your data? Then you need to do what? That data you cannot directly feed into the system or model. So what you need to do is you need to do some kind of pre-processing techniques we need to apply. Okay, on the data, so we need to develop some more features. So that's what feature engineering which we need to do. Okay, so if you look at so the data can be, as I told you, different sources for the data. Okay, you can have, okay, some numeric data, you can have some, okay, graphical data, some kind of the text data, images data, some credit information, time series. So the series data, which normally which we connect from energy prediction, energy type of cases or medical devices, we get some series of data, time series data. Okay, the data also involves so the dates and times, the calendar data. So all these different types of data, even data also contains the geographic locations, longitude and latitude. Okay, where we have to predict the distances and okay, the durations to travel and all. So the data can be geographical, data can be get from the databases, it can be of images, it can be of some credit card where a transaction is performed, a customer is performing set of transactions, okay, using some set of credit cards. So the data can be a text data, okay, data can be, okay, some strings, it can have some strings, it can have some numeric data. Okay, so all the different types of data will have, and we need to handle all these types of data. Okay, so handling this type of data, and we need to create some transformation variables. Okay, the type of, and we are going to create a new variables from the given set of data. So that is what feature creations. So those feature creations we need to perform. Then once the data is okay, will be, as I told you, that data is always, okay, we'll get some noisy data. Okay, if you see another picture. So as I told, these are the different types of formats of the data which we are going to receive for our application. And the data is always not clean. Okay, cannot be clean. So what? So sometimes if you look at this image, data can be very messy. Okay, if you look at very messy type of data, so we need to clean the data before giving to the model. So the raw data, the messy data, which cannot be fit into the machine learning models. So what we need to do is we need to apply the data cleaning techniques, data pre-processing techniques. Okay, this is what okay, what we say feature engineering. So feature engineering is a process of extracting useful features. Okay, extracting useful features from the raw data using our mathematics and statistics, and we can use some domain knowledge even. So definitely, okay, we need to have a lot of domain knowledge. Then only we can apply the data cleaning or data sampling or data transformation, data sampling, all these things. Okay, so to apply the data pre-processing techniques, definitely the the developer or okay, the person who is going to develop the models are going to use the data and going to get the to solve the problem. You need to have, okay, you need to have all this okay, the domain, okay, whether it is it a healthcare domain, then only you can understand, okay, what is the healthcare data. Okay, in terms of, let's say for example, when you are submitting claims, okay, to the insurance carriers, different carriers will have different data, and insurance claims will have different types of information. Okay, what is the provider information, what is the carrier information, okay, what are the procedures the provider is performing on the patients. Okay, so you need to have that domain expertise, then only we can apply, okay, some the pre-processing techniques. So to apply pre-processing technique, we need to apply the domain knowledge, we need to have domain knowledge, we need to have mathematics, statistics. These are all basically what I am going to say. These techniques are okay, manual kind of thing. Okay, now we have for all performing all these type of things, we have the neural uh, neural technology. Okay, neural networks we can use. So as I told you, okay, pre-processing the raw data into usable format. So as a process of pre-processing, as I told you, that feature engineering is a process of extracting useful features from the raw data using what mathematics, statistics, and domain knowledge. So definitely we need to have the domain knowledge. So for example, if you are solving a problem, so whether it belongs to a healthcare domain, a retail domain, different types of domains will be there. You need to have a domain knowledge. We need to have mathematical and statistics. The mathematical statistics now we can achieve with neural networks. Okay, even we have a lot of libraries provided by Python. Okay, we can use those libraries and we can apply for the pre-processing techniques. So in case of pre-processing, okay, so what is the pre-processing techniques we have? Okay, so preparing and preparing the raw data into clean usable format. Okay, this is what definitely useful for improving the ML models. So directly we cannot feed the raw data, okay, the noisy data into the system. So the data can be, okay, so we can have missing values, okay, we can have null values, okay, we can have non-values, NaN, okay. So different types of data. So all those, and we can have different types of data, as I told you. Okay, we can have text data, we can have some categorical data, we can have numerical data. So the text and the string and the categorical data directly we cannot give it to the model. So you need to convert. Okay, you need to transform the text data into, okay, a numerical format so that our model understands. So that's why what we are going to say is majority of the projects are going to spend majority of the time, 60% of the time, that's the analysis, on the data pre-processing. Okay. So Is it clear up to now? Anyone? Is it audible? Everything is going fine?
Yes, sir.
Thank you.
Yes, sir. Yes, sir.
Yes, sir.
Thank you. Okay. So the data pre-processing basically, okay, handling missing data. What is missing? What is the removing of outliers? So scaling, some sort of normalizations. Okay, all the variables will be not in terms of same type. Okay, we need to scale. Okay, then we need to understand what are the outliers. So to understand the outliers, to understand to fill the missing values. Okay, definitely you need the domain knowledge. That's what I want to say. Okay, domain knowledge. So encoding category variables. So what you need to do is what are the categorical variables? So those variables directly can't feed into the machine learning. So we need to encode. So we need to transform all the strings. Okay, all the text data. We need to convert into some binary format. You can use ones and zeros. Yeah, okay, different ways of handling the categorical values. Okay, so let's take some sample here. Okay, some type of data where I want to have some feature I want to extract. I want to predict Titanic survival. I want to predict the market sales. So there, in this particular picture, in this particular image, we have some type of data, some raw data, where you can see, okay, different types of data is there. Some numerical data is there. Some categorical data is there. Okay, some strings are there. Okay, some strings are there. So all the different types of data is there. Even the data can also have the dates, okay, and times. So from this data, we need to add some more variables. Okay, some more variables. We need to transform the given data into some more variables. That is what features. That's what feature. And okay, we need to identify features. Say, for example, if you look at okay, in this particular okay, in this particular data, okay, if you look at we have the columns FD. Okay, these are all related to the okay FD data and food. Okay, food data, dairy. Okay, then drinks. Then FD stands for food. Okay, NC. Okay, this is the household items. So all the item identifier will have some, the first starting two letters will identify what is the type of, okay, the row, what is the type of the row. So if we divide and if we get a new identifier, we call it as item identifier like FD and DR. And if you have one more column here, okay, so where we fill with that, okay, with FD and DR and NC. So that is what we are going to identify one more feature, one more variable. Okay, that is what feature extraction. Okay, we are identifying one more feature here. So with this value, okay, we can perform, okay, we can perform and we can infer some more data. Okay, how many are food items, how many are drinkable, okay, non-NC. Based on that, we can. So if you look at one more here, if you look at in this data, we have Mr. and Mrs. Okay, so here also we can add some more columns. So adding some more columns, and we have to perform. Okay, we need to change. We need to add some more columns. Okay, to handle this categorical data and to handle the strings. Okay, and we need to fill the missing values. There are some missing values. So always data will have all the noisy. Okay, so it can have null values, it can have some missing values. Okay, it can have some outliers. Okay, so for example, sometimes by mistakenly, okay, the age of a person is given something like 500. That is what an outlier. It is not a usual thing. Okay, negative values of our age. Okay, They are all what we call it as outliers. So we need to identify outliers and we need to remove the outliers. Okay. Sorry, can
సుధాకర్ సార్ అన్మ్యూట్ చేసుకోండి.
Sir, please could you unmute yourself, sir, please?
I've unmuted now. Are you able to see my screen?
Yes, sir.
Sir,
Thanks.
Yes, sir. Yes.
So as I told you that you need to able to handle different types of data. Okay, you should able to handle the missing data. So for handling the missing data, and you should able to handle the categorical data. You need to handle the different both type of data. You need to remove the outliers. So for all this, we need to apply some techniques. Okay, we apply some techniques and we remove and then we clean the data. Then that clean the data will fit into the model. Then we'll be training the data. Okay. So if you look at missing data imputation techniques, as I told you that, so if there is some missing in case of numerical values, numerical variables, so what we can do, we have different techniques like mean, median, okay, imputation and arbitrary value imputation, end of tail imputation. So different types of techniques here we use. So the missing values, okay, sometimes can be replaced. Okay, some value we have not provided, so we got some error while we are getting the data itself. Due to that also we can miss the data, and the data itself can have, and the provider who is going to provide is not willing to, okay, provide the data. In that way also we can have the missing values. Okay, someone is not able to provide his age, date of birth. Okay, so there also will get we are not able to get the value for that date of birth. Okay, so there are different reasons for getting the missing values. So you should able to handle the missing values. So for that we use what different techniques like mean. Okay, what is the mean value, and we need to calculate what is the mean value, and we need to replace that missing value with that mean. Okay, mean or median. Okay, and arbitrary, you can choose any value and can substitute any value, and we can use the end value, means what is the maximum value, we can replace that values. Okay, then if you go to categorical variables. So for categorical variables, what we can do is, okay, we have to again replace what are the different categories for each values. Okay, again it will also have different way of filling the categories. Okay, sometimes, say for example, okay, I told you what, say for example, cat is a category. Okay, monkey is a category. Then say for example, dog is a category. So different types of so category means a string. Okay, which cannot be fed into the model, which cannot be fit into the model. We need to replace, okay, the words like cat, dog, okay, monkey with, okay, some numeric value. Okay, for that we can use a separate column like cat. Okay, and we can replace, okay, the each row in that. If the cat is there, we'll put 1. If not there, we'll replace with 0. So that is what adding for each category. We are adding a separate column in the data set. That is what handling the category data. So in that, we can go with the binary value, or else we can go with okay, how many times the category word is used, what is the frequency, okay, how many times the frequent it is frequent. So those many values. Say for example, cat is appeared 10 times. So we can replace wherever cat is there in that row, we can replace that with 10. So that's the way we represent. And say for example, monkey is there say 15 times. So we can replace that monkey, okay, in that column for that row with 15. Okay, we can go with 1, or we can go with any the frequent, how many times it is. Okay, so for that, so if the value is there, okay, if the value is there, then we can add, say for example, if the we can also add one more word called missing. So missing itself is a category, okay, for handling the missing categories. Okay, suppose there's some categorical value is not there, some categorical value is not there, so that we can handle as a missing category, and that we can say a missing column we can add, and for that missing we can say if the value is not there, we can give what 1 for that matrix. Okay, so then yeah, both, okay, handling the numerical missings and categorical missings. So for example, as I told you, okay, if you look at, so this is my raw data. Okay, if you look at one of the raw data here, so the square feet is 2,300 is the square feet, and price is okay 90 lakhs. So for square feet of 2,300, the flat, okay, the cost is 90 lakhs. For a square feet of a flat 3,100, the cost is 150 lakhs. So the cost is given in lakhs. Okay, so if you look at this data and you need to add some more column, okay, we are adding some more column like price per square feet. So that means this is giving some knowledge, okay, some KT for that. And we are getting what is the knowledge, and we are adding some more column for this. So price per square feet. So if we calculate, so we'll get the price. So in this, how do you handle the outliers? Okay, for a sample of handling the outliers. So for example, if I have I'm a real estate person, and I know, okay, in this particular city, say for example, this is a Bangalore city. Okay, the price per square feet cannot be less than 3,500 or 3,000. Okay, if I have that particular domain knowledge, I can say this is an outlier. Okay, so this particular row is outlier. So the price per square feet here, it is 500. So to identify the outliers, sometimes we may need to introduce another columns, okay, which gives us some, okay, some domain. We can apply some domain knowledge, and we can find what are the outliers in the given raw data. And we can also plot, okay, we can go with visualization, some bar chart, and where we can identify what is okay, what is the outlier in this data. So we can also apply some two standard deviations, some mathematics and statistics algorithms we can apply on the given raw data to identify the outliers. So outlier detections, so we can remove these outliers because those outliers is going to influence, and which is going to create the skewed, okay, left skewed or right skewed data. Okay, when you plot a bar chart, okay, the diagram, so the graph diagram, so you can see this more skewed. So you can eliminate the skewed things. Okay, for that also we have a lot of techniques for elimination of skewed data. Okay, so those we need to eliminate the outliers. So to identify the outliers, look at here in this example. Okay, we have transformed the given data into another. We have added one more column here, and we have applied our domain knowledge where the price is greater than 3,500 in that particular area. Okay, in that particular locality. Say for example, in Hyderabad locality, minimum the price will be per SFT 3,500. If I have that particular domain knowledge, so that helps me to identify the outliers. So again, visualization. So these are all actually when I am applying domain, I can't see each row and go and apply my domain knowledge on the each row. So this is a manual thing kind of thing. But now, okay, when I told you, okay, by using the neural networks, okay, and the different libraries, okay, which we have, and we can apply all the library, the algorithms to identify the outliers also. Okay, we can use our programming techniques. Okay, and if you go to this another data where we have some missing data. So handling missing data is one of the, say I told you that the mean, okay, what is the mean value for this, and we can replace we can fill this with mean values like 3 3. So for the mean for this is 3, and I have replaced the missing values with the 3 3. Okay, so you can ignore. So you can eliminate null values, you can eliminate rows with null values, you can eliminate sometimes you have to ignore. Okay, so these are all okay, the techniques, okay, for filling the missing values and for identifying the outlier detections. So next, if I told you the categorical encoding, the most important categorical encoding technique is one-hot encoding. So one-hot encoding is, as I told you that, just I gave you an example there. Okay, when you have for each category, we add a column. Okay, we had a one column. For each category, we had a column. So in given data sample, okay, in that column, so I have 5 unique categories, categorical data is there. So I need to add 5 columns, and then each column we need to give what 1 or 0, whether that value is there or not. Okay, then other technique I told you. So count. Okay, we need to how many times that categorical item is present in that. Okay, as I told you an example. Okay, a cat is appeared 10 times, so I replace in that column wherever the cat is there in that row, I replace the value with the 10. That is what count or frequency encoding. Then ordinal labeling. So you need another way of doing it. Then we have already studied like mean encoding. We need to find the weight of that. Then another thing is binary encoding. So binary is there are so many other techniques, alternative techniques for handling the categorical data. So for example, we go through this example, you can understand.
Share the full screen, sir. Sir, can you share the full screen?
Yeah, I think I'm sharing, no?
No, it is not visible. And others have also raised that concern on the chat box.
Okay.
It's visible, sir.
Sir, could you select a hide presentation view, sir? Could you select hide presentation view so that could please can you share one more time, sir? You please present it.
I'm not presenting.
Either click on F5, sir.
I clicked on F5. Let me again present. So it's coming or not?
Currently, it is showing blank screen.
Okay. Then I need to close this PPT then. Okay, is that clear now? Is it clear?
Blank screen, sir. White, blank.
Oh. Sorry for inconvenience. Still? Hello?
Sir, it is visible, but it's better you keep it in means not slide mode. Earlier you have tried. This is not visible. It is very small.
Okay.
Sir, the issue is that on our screen we are able to see the preview of the next slide also. So the portion is
Oh.
divided into 2 slides.
Oh, got
So
it.
the present and the next slide is also visible.
Okay, got it. Still?
Yes, sir. Still
It seems
both
much
the slides
better.
are available.
But it is much better.
Okay. Okay, bear with me. Okay. Yeah. So as I told you, okay, the next slide. In this, you see, this is what the categorical handling of categorical data. So in this column, I think you are able to see in this column with the values. Okay, we have 3 different types of values. So this is what a categorical value. Okay, for each handling categorical value is what for each value. Okay, we need to add a new column. So I've added this column. Okay, then this is another column. So for each column, we are going to add a different column for this. Okay. So if the value is there in that row, so we'll be replacing with 1. Okay. So by this way, we will be filling the we'll be getting the category and handling the categorical data. This is what say for example here we'll get okay this in this row we don't have this.
Sudhakar sir,
Yeah.
sorry for the interruption. I think you are sharing entire screen.
Yeah.
Better to keep in the slide mode and share the window.
Okay.
Yeah. Then slideshow పెట్టేసేయండి.
Yeah, I slides on a పెట్టాను. Then
Slideshow పెట్టేసి better to share window.
okay. Then I need to go with Visual Google and
Share window.
stop presenting first. Share window.
Full screen ఉన్న window share చేసి.
Still edit same.
మీరు స్లైడ్ షో చేయలే.
Slide show చేశాను.
F5, sir.
Fine.
మీరు జస్ట్ మీరు స్లైడ్ పీపీటీ ఈ విండో కనబడుతుంది, స్లైడ్ షో విండో కనబడుతుంది. బోత్ యూ కెన్ సీ వైల్ షేరింగ్ ద స్క్రీన్.
Okay, okay. Got it. Is it clear now?
Yes.
దిస్ ఇస్ పీడిఎఫ్.
No, PPT.
Okay.
Is it clear?
Not visible properly.
I shared the other window. I have two monitors, Sadhana.
No, sir.
This is browser you are sharing, sir. Actually, you enable you did not enable presentation view, sir, in PPT.
Okay.
Sir, PPT share. Can you share to my WhatsApp? My scholar will present it. You can. Okay.
Or did I lost? I think. You want to share? Send me. Send this one. Is it clear? Is I'm audible? Sadhana?
Audible, sir. This is not in slideshow actually. Only. Can you share the PPT to me?
Okay. Yeah.
Chandar?
Sir,
Online లో ఉన్నారా? వాట్సాప్ లో ఉన్నారా?
yes, sir.
Okay.
Is still the issue now? Sadhanam?
Sir, share కావట్లేదు. It's not sharing.
Oh. Okay, let me send you then. I shared. So anyone is going to share? No? Or-
2 minutes wait, sir.
Yes, okay.
Sir, I am sharing, sir. Wait for 1 minute.
Yeah, can you go to next slide? Yeah. Next. Yeah, next. Yeah. Yeah, thanks for doing this. So this example, whatever the example are now you are seeing on the screen, is handling the categorical data. So if you look at the first row in this, okay, the first column in this, okay, different types of values are there for each type of. So we have 3 types of values. For each type of value, we have added for each type of value we have added a column. So 3 different types of values are there, and we have added 3 different types of columns in that. So in that column, we have that. So for if the value is present in that column, so we are going to give the 1 value. If not, we are going to substitute with the 0. So for the first 5 rows, okay, in case of the Monori township, we got all the 5 values. And if you go to the remaining values for that column are 0. So that means the value is not present in the remaining rows. So that's how we are going to fill the data. Okay, this is what handling of the categorical data. Then if you go to the next slide, please. Yeah, this is what kind of called another technique, okay, where we use the scaling, so the data transformation. So we want to scale the data. The data has different types of okay, different categories, different types of data. So for example, if you have okay, say for example, if the salary is in rupees, okay, sometimes in other cases thousands, In some other column, we have in lakhs. So we need to brought all together into one. So we need to scale. So we need to scale and we need to normalize the data and the uniform values. So for that, so the scaling always changes values between 0 to 1. So it will bring the values into normalized format so that we are going to stop that kind of what the skiing, left skiing or right skiing, okay, for that. And if you look at the other thing is what already we have gone through this, the encoding means converting categorical variables into numerical representations. So where machine algorithms can understand only the numerical values as we studied. So that is what another part of it. Next slide. Yeah, this is sampling. This is another technique here. So the sampling is, okay, we can't say sometimes we don't want to deal with the entire data. We want to take the some sample of the data and we can get the same predictions. So if you look at first image, we have in the first image will be having 8,000 points. Then we reduce it to what 2,000 points, then 500 points. So we'll be giving some part of the data. Okay, that's where we'll be getting what some we can handle the data. So sample represents approximate the same property, okay, as the original set will have. So all the properties of the original data set, the sample will also have. So we are not dealing with the entire data set. We are going with what some sample of the data, and we'll be predicting on the sample data. So then we'll be concluding on the complete overall data. So this is what another sampling technique. Next. So as I told you that we have so many algorithms. Okay, we are not going to do all these pre-processing techniques with manually. We need to use what the algorithms. We have some open source softwares are available, okay, for the extraction of these features. So the samples, the open source softwares are okay. If you look at the Learn and TS Fresh and Spassy, these are all feature engine. They're all the open source softwares. So the advantage of open source, okay, and you'll also have sometimes the drawbacks, but definitely all those going to be fulfilled, okay, when you are going to use the open source. And with the use of these open source softwares and the libraries, we are going to, okay, pre-process the data, and we are going to feed into the ML models. We'll be fitting into the ML models, okay. So next. Yeah, why we need to use the open source? Definitely the cost is one of the thing. Okay, we don't want to spend a lot of amounts in buying the new softwares. Okay, and other thing is all the code is already tested, well tested code. Ensure it works, and we'll be getting a version for that, maximizing the reproducibility, increase the performance, and reduce deployment times. So you need not deploy the softwares always. So, and definitely you can also suggest, okay, sometimes you'll get some wrong results. Even we can also these are all open forums, okay, we can raise the tickets and the kind of thing. They can prune it, and we'll get the correct kind of thing. So we need not spend a lot of time on it. So we have all the open source softwares available, and we can use those softwares to perform the pre-processings. Okay, next. Yeah, the challenges. Okay, the feature engineering, as I told you that. So it involves a lot of code. Okay, we need to do a lot of code. We need to do definitely, because as I told you that in the initial slide itself, Okay, the maximum amount of time which we spend in the project is what? The pre-processing, the feature extractions, feature engineerings. Okay, so we need to lot to code. Then all these things are repetitive. Okay, definitely we need to do what handling the missing data. Then for everything, okay, this is all repetitive tasks. Same techniques we use. Okay, and more time consuming thing. And we need to learn, and we need to save the parameters, and we need to reproduce. So these are all the challenges of feature engineering. Okay, thank you. Next. Yeah, thank you. Sadanam Garu. Any doubts here?
Sir, can you show that how it is done? Some demonstration, like sampling and all the cases you have shown.
Hmm.
So how we are using the tool, some sort of live demonstration, little bit.
Sorry, actually, I didn't loaded all those.
Okay.
Okay. Yeah. Any more things? Normally, we are also okay in our application. Also, we are going to use it. We are our application is what healthcare domain application, and as I told you that our application is one we call it as paid EC. Okay, pay the doctor, pay to doctor kind of thing. It's a chiropractic software, and we have lot of data. Okay, so we apply day to day, and we are also building for the customers. Okay, the new features, and we are attracting the customers. Okay, by providing the new features on the application. So this is a legacy application. So our application, which I am working for last 10 years. Okay, I'm working for the same application where this application is used by many clients in the US, around 1,000 clients they are using. Okay, this software is it's a chiropractic patient software, and we have lot of data. Okay, of patients. Okay, then the appointments which we are scheduling the appointments. Then we have different modules like the scheduling of appointments. Then patient demography kind means taking the patient details. Okay, then what are the what we say the case, the what we say the care plan. And say for example, if the patient comes to the organization, as to the office or to the hospital, we plan the care. So what are the activities we need to perform for the patient? So, and based on what type of the problem is coming for the hospital, so we diagnose the okay. So we have a concept called the subjective and the SOAP net, what we say subjective, objective, and assessment and plan. So we are going to plan a procedure for what type of okay, how many times the patient is going to visit the hospital. So based on the data, we can give the doctor or the provider, okay, so the number of times, and we can predict how many times this patient is going to come to the hospital for a given symptom. Okay, we need to do what and we are doing what we are training our the database, okay, to get that type of data. So once the provider performs, okay, the care, and he performs the procedure, he identifies what is the problem for the patient. Then he'll identify what type of procedure he need to perform to the patient. Then he'll perform the patient. Every procedure he is going to perform is associated with the cost. Okay, so based on the type of the problem, we should able to predict the bill. Okay, what is the cost of it? So that's what we are suggesting the clients who are using the software, and we are building the models on it. So it is still in the process, and definitely what we are going to do is once the every patient will have in US, the healthcare, okay, is very costliest thing in the US. So every claim is and every patient is associated with some insurance carriers. Okay, once the patient is billing is done, we need to send a claim in a particular format. So we'll have different formats for sending the data. We know 835 format and 837 formats, different formats. So all this, so when we are sending the data to the insurance carrier, okay, sometimes 50% the claims which you are sending to the carriers is going to be rejected due to what insufficient of the data. So there also, okay, we are suggesting, right, this is again a project for the client, a new project for the client. Okay, if they approve, okay, definitely. So we will be telling what are the advantage. Okay, by applying this machine learning algorithms, okay, we can tell the clients that the prediction of denial of the claim will be very less. So what we need to do is, while before sending the claims to the insurance carriers, the third party carriers, okay, the what we say clearing houses will be there, intermediate. And we want to eliminate the clearing houses. Actually, the job of clearing houses is what they need to receive the claims and clean those claims and send the claims to the insurance carriers. Okay, so we want to eliminate that the cost which is paid by the clearing houses. Even the clearing houses will again return the claims back to the client, saying that this claim is not having the proper information, and this codes cannot be applied to this particular patient, and this patient is not eligible for this much amount. Okay, so all these things that so because of all these things the claim is going to be denied. So in every domain we can use okay, the algorithms. So what we need to do is before sending the claims to the insurance carriers, that to minimize the denial of the claim payment and to reduce the time. Okay, patient cannot wait, or the hospital cannot wait till the amount received from the insurance carriers. So to avoid that time, what we need to do is we need to clean the data, we need to send the data, and we need to predict whether this claim is going to be rejected or not. So in which cases the claim is getting rejected. So when we are submitting the claim, we need to alert, okay, so that this claim is going to be rejected. Okay, that's why definitely we need to have the models. Okay, we need to have the ML. Okay, so every program will have the models, and definitely we need to train the data, and we need to apply the machine learning algorithms. Okay, in terms of our application, I just told you that claim rejection, lot of things say care, how many visits are required for this particular patient, predicting the number of visits well before. Okay, saying that advancedly saying the patient. So this is the approximate cost you are going to bear. Okay, so that is predicting the cost for a given okay, some, say for example, he came for particular diagnosis, he identified some diagnosis, and if this particular diagnosis, if he is diagnosis for this particular problem, okay, what is the rough cost and how much he has the insurance payment, so how much he has to pay from his pocket, patient payment. Okay, so those all we can predict roughly well before. Okay, well handy in the, and we can reduce the cost, and we can reduce the time, and we can reduce the amounts, and where we can optimize our system. Okay, by accepting and by eliminating these claim denials, and by predicting the total number of visits required for the patient. So this is how what a developer normally not only see generally so far what I told you what I say my biodata looks like. I'm basically working on WPF. Now recently we are migrating our application to the web, okay, where we'll be using the Blazor, and also we are trying to use all these techniques, okay, pre-processing techniques, and apply the pre-processed data to the ML models. Okay, we need to train the models, and we need to get the some kind of predictions. So and we should able to tell, and we know the domain knowledge, and we know all these things, but we need to explain, we need to convince the clients. And if you have these knowledges, so as a developer, definitely, okay, if you build some few models, and if you tell the clients that, okay, by applying and by going with this type of projects, by applying some machine ML algorithms, okay, you are going to get, these are the benefits. Okay, what is the benefit? You are going to give a new problem to the client. Okay, and you are going to give the new revenue for the company where you are working. At the same time, not only, okay, in general, okay, ML, okay, makes people life very happy, and in the sense, okay, in terms of time and predictions and all, okay, a lot of things, as I told you, if you don't do, okay, the denial of claim predictions and all, so a lot of unnecessary time taking process is there. At the same time, okay, the cost is involved, so we can minimize all those things. So this is related to one of the domain which I'm working on it. Okay, so we have already presented a lot of ideas to the client and our company, and we are building. Okay, the client is now agreed for that, so we need to build it. So for any application, say going forward, if you not a data scientist or not a, okay, machine learning guy, but definitely if you are working for a software company or you are going to train your students, so the advantage of okay, learning the machine learning, okay, and you should able to, okay, predict, say for example, there are a lot of advantages. In the first slide we have gone through the, okay, market analysis in case of stocks, okay, then frequent patterns, machine learning mining frequent patterns. So the advantages you need to explain to clients where we are working, we can get a lot of revenues, and yeah, that is what in terms of my application where I'm working on it.
Okay, sir.
Thank you.
So, friends, any doubts from your end?
Yeah, actually, it would be better. Actually, I would have come with some practical sessions. Not planned actually.
Okay, sir.
Thank you.
Thank you, sir. I extend my heartfelt gratitude to Sudhakar sir for delivering an insightful session on data processing and feature extractor. Your guidance on managing missing data, identifying outliers, and handling errors has provided with us with practical techniques and improved data quality and reliability. Once again, thank you, sir, for giving this great session and sharing your expertise. Thank you, sir.
Yeah, thank you.
Okay.
Thank you. Bye.
Okay.
Bye all.
Bye, sir. Bye,
All
sir.
the best. All the best to all. Bye.
Thanks. Dear participant, next session will start sharp 7:30 p.m. Okay.
Okay, sir.
Okay, sir. Thank you, sir.
Sir, whether we need to wait or quit, sir?
Ma'am, you can wait or join exactly at 7:30, ma'am.
Okay, sir. Okay,
Okay. I will drop message in the group.
okay, sir. Okay.
Good evening, sir. Shall I leave it from until 7:30 p.m., sir?
Yes, sir.
Excuse me, sir. Am I audible?
Sir, yes, sir.
Sir, due to some network issue, I have disconnected for 2 minutes in the middle of the session.
Okay,
No
sir.
issue, sir.
No issue,
I
sir.
have observed it, sir. No issue. Right.
Please, sir. Okay. Thank you. Thank you very much, sir.
Okay, sir.